today. Today's video is going to be real quick. It's going to take two lessons and combine them into one video. We're going to take 14.1 number sequences and 14.2 number rules, and I'll show you how to do that real quickly. Today in class, everything seemed to go very well, so I don't think this will pose too many problems for you, but if it does, watch this video and you should get some good reminders. So first, we'll deal with 14.1 number sequences. That's these numbers here. Basically, I want to ask myself, how am I going from this number to the number after it? So, how can I go from 3 to 7? Well, I notice all of my numbers are getting bigger. So, I'm either going to add or multiply. I can't add, or I can't multiply 3 times anything and get 7. So, how can I go from 3 to 7? I'm going to add 4. Now, I need to do a couple different jumps here to make sure that rule applies for the entire length of numbers. 7 plus 4 does equal 11. 11 plus 4 equals 15. Now I want to fill in simply the next three numbers. 15 plus 4 is 19. 19 plus 4, 23. 23 plus 4 is 27. It's that simple. So our rule here would be to add 4. Next one, I have an example. You'll notice my numbers are going from big and they're getting smaller as they progress down the line. So I can either subtract or divide. Well, I know I can't divide 24 divided by anything and ever come up with the number 20. So I'm going to use the subtraction rule. I just need to figure out what it is. So how do I go from 24 to 20? I'm going to subtract 4. I have to make sure this applies for the next couple. 20 minus 4 is in fact 16. And then I need to fill in the remaining 3 missing numbers. 16 minus 4 is 12. 12 minus 4 is 8. And finally, 8 minus 4 is 4. Pretty simple, not too difficult. If I were to ask you, what are all these numbers multiples of? Okay, they're all even numbers. Every single number I wrote is an even number, so they're certainly all multiples of 2. However, if you take a closer look, they're also all multiples of the number 4. So when I skip count by 4s, I'll say every single one of these numbers. As a matter of fact, in reverse order, it's basically a list of multiples of 4. 4, 8, 12, 16, 20, 24, and so on. Next one I have here, 5, 10, 15, 20. I can either, again, I'm going from small to big, so I can either add or multiply. Well, in this case, I can do two things with this first jump, so I need to figure out what I can do. I can either do adding. 5 plus 5 will get me 10. However, 5 times 2 is also 10, so I need to figure out which rule I need to apply. So it's either going to be plus 5 or times 2. So now I need to apply the rules to the second jump. 10 plus 5 is 15. 10 times 2 is not 15. So I found my rule to be the plus 5. And I'm going to follow that rule as I move forward. 20 plus 5, 25. 25 plus 5 is 30. And then 30 plus 5 is 35. It's important to try both rules as you move forward, just in case one works one time, as it did here, and doesn't work going forward. Finally, the last one. I started 18 and I am progressively getting smaller. So from 18 to 15, I'm either going to divide or subtract because I'm going from larger numbers to smaller ones. I know I can't do 18 divided by anything to get to 15. So I know it's going to be a subtraction one, and it's going to be to subtract 3. 15 minus 3 is 12. 12 minus 3 is 9. 9 minus 3 is 6. And 6 minus 3 is 3. Here, you'll notice that they're all multiples of 3. Keep that in mind. As I count by 3s, I will say every single one of these numbers. Up here, these are all multiples of 5. So that's basically 14-1, finding the rule going from the beginning number to the number after it. Now on 14-2, titled Number Rules, okay, your book will always give you what the rule is. However, I'm not going to make things that easy. So what I'm going to do here is tell you where I'm starting and tell you where I finish, and we are going to figure out the rule together. So I'm starting here at 27. I call this my ins. Coming out, I'm getting a 9. Well, how did I go from 27 to 9? I'm going from a big number to a small number, so I could do one of two things. I can either subtract or I could divide. Well, I know that 27 minus 18 is going to be 9. Okay, so it could possibly be minus 18. However, I could also do 27 divided by 3 to get 9. Divided by 3. So here's an instance where I have two rules. I need to see which one of the two works moving forward. Well, 21 minus 18 is not 7. However, 21 divided by 3 is 7. So now I found my rule to be divide by 3. (18) divided by 3 equals 6. And I need to fill in the remaining missing numbers. I'm going to use the same rule I used the whole time. 15 divided by 3 equals 5. 9 divided by 3 will give me a quotient of 3. And 6 divided by 3 will give me a quotient of 2. And again, your book is going to tell you what the rule is, and you just have to simply figure it out. But in case you ever come across a problem where they don't give you the rule, this is how you can figure it out. Same idea here. I'm going from small numbers, and I'm getting out larger numbers. I can either add or multiply. Well, to go from 3 to 18, I can either add 15, or I could also multiply by 6. So I can either add 15 or multiply by 6. Let's see which one works with this. We're going to do 5 plus 15 does not equal 30. However, 5 times 6 equals 30. So I found my rule to be multiply by 6. Three times 6 is 18. 5 times 6 is 30. 6 times 6 is 36. 8 times 6 is 48. However, here we go. I'm missing a number here. I'm missing my ins, but I have my outs. So I need to ask myself, what number, what missing number, times 6 is going to get me 54? So, knowing my multiples of 6, if I skip count by 6s, I'm going to skip count 9 times till I get to 54. 9 times 6 equals 54. It's that simple. It should not be overly difficult. Take your time. Make sure you work through a couple different jumps or a couple different rules on your chart to make sure you found the proper rule, because I showed you a couple examples where it could be either addition and multiplication, or it could be division and subtraction, and you're going to have to work your way through it. Thanks for watching.